Hello and welcome to the Mid-Toyo America Corporation M3 Metrology Solutions Center in Aurora, Illinois. We are located at 965 Corporate Boulevard, and my name is Donna Booth, the showroom coordinator. This is one of several showrooms throughout the United States. The showroom is designed to allow customers to have a hands-on experience with Mid-Toyo products such as coordinate measure machines, vision and optics, form equipment, sensors and encoders, plus hand tools. Bring your metrology challenges and let us find a solution. To see a list of showrooms and to schedule an appointment, visit our website at mitutoyo.com. That's mitutoyo.com. Today's event, we will focus on the Mid-Toyo Precision Laser Scan Micrometer, starting with a short presentation by Michael Grosenbach, product specialist. Next, a hands-on demonstration, followed by a question and answer session. Now please welcome Michael Grosenbach.
Great, thank you. Again, my name is Mike Grosenbach. I am the product specialist for hand tools and sensors. Hand tools including calipers, mics, indicators, height gauges, and sensors including contact and non-contact, which would be linear gauges and probes, or laser micrometers, the non-contact side of it. And today we're going to talk a little bit about laser micrometers, why it matters. So no matter what study you look at nowadays, you're going to see that the usage of sensors is increasing. It's the future. It's where things are going. The Americas is huge with this type of market as well. It's increasing dramatically in the Americas. So lasers, I'm not going to go into the history of lasers because everyone knows what they are, but how do we differentiate ourselves? What's changing in the world of lasers? So one of the things that we're doing differently is the way that the lasers are being used is being used much more accurately with methods to compensate for pitch error, and things like that within our products. But also, I don't know if you knew, but laser is an acronym for light amplification by the stimulated emission of radiation. I don't know if you knew that, but within the last few years, I didn't really know that. So what is a laser micrometer? Why are we here? What are we talking about? So a laser micrometer is basically a ribbon of light that you put a part in place and it's measuring the diameter of the part. How it's doing that is through this. We have a semiconductor laser and it's bouncing the laser off of a spinning polygonal mirror, which is going through a collimating lens so that you get that ribbon of light that shoots straight across, a condenser lens to the photoelectric receiver. And then through timing, it's actually scanning top down. It's actually giving you the measurements through this principle. And you can measure any of these segments, whether it's the light segment, the shadow, or this light segment. And why that matters is because you can use any of them to measure. So normally what people think about with the laser micrometer is they put a part in, they get a diameter, and that's it. But you can rotate that part to get an ovality. So why do I care about segment 1 and 3 then? Those will actually give you, if you rotated them, a TIR or runout. So oftentimes what you hear in the marketplace is runout and TIR. So these would be the units that you would be using to measure to the part from the top or from the bottom. So the Mitutoyo lineup includes everything from something that measures down to 5 microns or 2/10,000ths of an inch, all the way up to 6.3 inches with a single measuring unit. We also have an all-in-one unit and an ultra-high accuracy unit here. And there's a lot of different features that they have, but you need to select the laser basically based on your application. The counter that we have now is the 6200. So it has a lot of different features as far as SBC, max, min, range, standard deviation. There's an odd flute mode in it. There are programs where you can use it to put in presets or tolerances. You can have different sets of tolerances per program, and it has outputs for RS-232 through the I/O port or Digimatic if you wanted to go directly into Excel, for example. So, and there's more to come, so keep that in mind as well. The QuickTool software is a free software that we have. There's a lot of features that these lasers have, but this makes it really simple to set up the laser. So if you had a transparent part even, you could just click transparent, click an OD, and your laser would be set up to use. There's also a basic data acquisition section to this software, so if you wanted to take some data, save it as a CSV to open up in Excel later on, you can do that as well. So what's so great about them? The accuracy is fantastic. You can get down to 0.3 microns or 12 millionths of an inch accuracy, and that's real linearity accuracy. That's not repeatability. So very highly accurate. They're high speed. If you have gauge R&R issues in your facility, maybe you have a problem between operators with standard micrometers, this is a great option for those types of situations. You can measure difficult parts with this, whether they're transparent, fragile tubes, fiber optics, extremely thin parts or hot parts. There's a wide range of applications that you can use with these. So we've measured everything from beer bottles to barrels to carbon nanotubes. So what kind of applications, where do you see these? Primarily recently, actually, we've seen an uptick in pin gauge calibration. There's grinding operations we've had them. So in line, this is a centerless grinding application right here. Fiber manufacturers, really any cylindrical parts though. There was a garden hose manufacturer that was measuring the crimps with a laser micrometer. So it's really all over the place though. So it's not just aerospace and medical, which is the highest accuracy applications. It's really anything that you have a turned part. Common requirements are diameters, runout, roundness, ovality, straightness, where you can actually slide it through and measure straightness as well with these types of with these lasers. So again, they could be in lab, which is what most people think of, or they could be in line like this centerless grinding application. So an example of applications, most people already know them for this. So if you're putting a part in, it's measuring a diameter, but you could also, using those light segments, measure the thickness of sheets. Say it's materials that are flowing through the laser, or you could measure these large barrels like this with two different lasers that are offset and inverted at a fixed offset. Here's an example of an odd flute end mill. So if you wanted to measure that, the way it does this is by tracking the topmost position as you're rotating it, and then tracking the bottommost position, and then giving you the difference between them. And then it calculates the effective cutting diameter, essentially. You could measure hot parts with this, again, hands off. Large diameters, again, these rollers. Carbon nanotubes, so these are really interesting with R&D. This was presented to us in a small frame, and it was so small that you couldn't see it unless you held it up to the light, and it was just like the finest spider web you've ever seen. It was pretty amazing. Tensile testing in radioactive parts, so again, hands off, definitely with radioactive parts. Tensile testing to see how the part is getting smaller over time, as well as film thickness. This is flowing through to measure the thickness of that orange trash bag film. This is an interesting application where they had a problem measuring with blade micrometers across these flats. So they're measuring this flats across this helicopter swash blade. And you can also measure, in some cases, inside diameters or OD diameters. So it has to be a certain application, but you can also do that. As far as accessories to support the part, we have quite a few that are already off the shelf. Stages that can be vertically adjustable or slide in and out axially, so you can measure various positions across the part. Air purge covers, so if you have a really oily environment and need to keep the lenses clean, you can use those. As well as something like this, which is semi-custom. This is a fixture that holds two lasers in place automatically, so you can measure the X and Y value of a part. Other semi-custom parts that we have is this work stage for very large diameter parts. You can use it in central supports or with these adjustable V's. This was a custom pin. It was rotating, and our solutions group here made this fixture to measure concentricity. This was another example that was very similar. It's motorized and sliding, so you could measure different diameters as it's spinning along the shaft of the part. So a quick overview again. Very high accuracy for lasers, high scan rate. They can be used in lab or in line. The gauge R&R is fantastic with these, especially if you have issues with reproducibility. You can measure from barrels to spider webs. We have off-the-shelf fixtures or custom fixtures, and the software that you can easily set the laser up with all these features. So I mentioned coming soon. So this is what's going to be the future. We have another processor where you have the same, essentially the same lasers going into a DIN rail mountable processor. And this will be great for PLC applications, and it has communications that will be available. It's going to be USB or CC-Link or Ethernet IP with these different cards that can fit in here. So it's going to be a very versatile, very easy way to communicate with popular American PLCs. So this is about the end of my presentation. There's going to be a hands-on demo section next, and then after that we'll open it up to the Q&A section. So at this point, let's move on to our next segment, which is the hands-on segment, and I have Curtis here to help me out with that.
Hey, how you doing? I'm Curtis Stubbs, your regional precision tool sales representative, covering the North Central 9 states here in North Central Midwest. First of all, make sure you go there, hit the post notification button, go ahead and hit your like, and make sure you go ahead and make all your comments there and suggestions in the comment section. Now, Mike, there's a few parts that I run into with my applications with customers and stuff like that out there in the field, and some of them are just round parts like this for checking regular ODs, right?
Right, absolutely. That's the most common application, is just measuring diameters like this. You've got something like a tube or a pipe or something that's been turned down, and you just want to measure a diameter.
All right, so I'm gonna go ahead and pop this tube here in our V block here. And we have a few programs already set up. Right now, of course, program 0, which is segment 2 for just diameters, all right?
Exactly.
We have those diameters rolling. Now, if I wanna go ahead and hit my continuous run button, I can catch the max, min, and a deviation from that. So let's go ahead and run through that.
So at this point with the continuous run, what he's doing is it's taking multiple measurements within that time where he started and stopped the measurements. So now what you can do is, of all those measurements, you can go in the statistics. This N is the number of measurements that he's taken, the standard deviation, max, min, average, and the last one here is the max minus min, or the range, right? So in this case, I think we were measuring probably a hole or something that was coming across. So this will give you the max minus min, and this is the roundness normally of the part, right? So this would be the ovality or roundness. So again, this segment 2 that we measured here, that is the first shadowed segment. So you can use the light segments or the shadow. So this was measuring the diameter directly.
All right, so now we talk about regular OD measurements. We're gonna go to get it set button and get out of here. We're back to regular measurement modes. Let's talk about a little bit more of another program we set up, which is program 1, all right? And then segment 3 for TIR, right?
Exactly, so what this is, segment 3 is the bottommost light segment. So you can see on that sidebar on the left, that's what that is. So here, he's showing the light segment there, but this light segment at the bottom is going to be the gap. So it'll be the same as an indicator measuring the bottom of the part, sticking up and measuring the bottom of the part.
So I'm gonna go ahead and do our same there, do a little run, shift and stat. All right.
So within that second or two that he took measurements in, he got 13 measurements. Here again is the standard deviation, max, min, and average. And here, the difference with this program is that since we're measuring the gap, this is the same as using an indicator. So this here, this R, is the max minus min, or the TIR, or run out of the part. So again, different from measuring the change in diameter, this is the difference in essentially the wobble, that TIR or run out of the part.
All right, so let's go ahead and press the set button to get back to regular measurement mode. We're gonna go ahead and go to a different program we set up, and let's talk a little bit about ovality, right? We touched based on that. So we have program 2, ironically. All right, here we go.
So program 2, now what we've done here is we're still taking a peak hold measurement, but say you didn't want to see all of those other measurements in it, right? So you only wanted to see the ovality measurement, right? So in this case, you could just hit the foot switch or the run button.
Right, and I'll use the foot switch. It's pretty cool to use sometimes, so I'm gonna go ahead and do that.
And rotate the part, so it's still taking a bunch of measurements and it's holding them internally. And once you're done, you hit the foot switch again. It pops up with the ovality measurement that you're looking for. So that could also be sent across to the computer. So if you wanted it to go directly into Excel, or if you wanted to send that to your SBC software, say it was MeasureLink SBC software, or your own software or programming, you could do this all through the Digimatic output, which is the Mitutoyo output, or the RS-232 output.
All right, that's pretty cool. So we touched base on a few of those. We go to another program we have, like for gap measurements, aka TIR, right? So ironically, again, in number sequence, program 3, segment 3.
Right, so here we're going back to segment 3 like we did originally. And the reason why we're using this is because the dovetail of this adjustable work stage is pretty nice, because it's actually cutting off the bottom of the laser and giving you a nice crisp edge, so that this distance to where the bottom of the part starts is going to be very accurate and repeatable.
All right,
so
same thing.
At this point, we'll do the same thing. We've set it up ahead of time just for peak hold. So we're still doing max minus min in this mode, but again, this is going to be the TIR. This is going to be your run out directly. So if you didn't want to have to toggle through all of those other values, then you could do it this way as well.
One more time, just in case our audience forgot to hit that again and missed it.
Yeah,
there we go.
rotate it a little bit more and you see a bigger run out.
Oh, that's pretty cool. So now we got all these touch pads and stuff like that. I know a lot of my customers that I run out there in the field, they say, well, can I be able to program this? And I say, sure you can. We got a free downloadable quick tool. So let's gonna show them how we can do the same thing, but with the quick tool.
So yeah, there are a lot of features that these lasers have. So this QuickTool software is a free downloadable software online, and you can access it. And right now you start up the software, all of the settings that are already in the laser are uploading into the software. So you don't have to remember where you're at or what settings you had in the laser, or remember any kind of presets. Everything will be uploaded into this automatically. So right now it's a nice GUI, nice graphic, user interface where you can instantly, click transparent or normal objects. So say you have clear tubing, excuse me, or fiber optic cable or something like that, you could do it here. Or in the edge measurement, if you had multiple components that you needed to measure, say between the top or bottom surface and of the top component to the bottom of the bottom component, you could do it with this edge measurement as well. Okay. You can easily change the resolution, blanked out digits. You can have dual programs here. So if you wanted to list the gap measurement and the diameter at the same time, you could do that. Here is the expanded setup. So if you did want to see everything at a glance, there's a lot more features, like I said, so you can see them here. Right. So if you wanted to change the type of go-no-go measurement, so say you wanted it to be, instead of just an upper and lower tolerance, you wanted it to be a 5-step tolerance. Maybe you're going to a light stack or a buzzer and you wanted to give a warning buzzer, you could set that all up right here.
Okay, so let's go to this next mode here.
So mode here, you'll see what your programs are. So each program again can be set up differently. So the way we had it, we had program 3 is doing the gap. And then here segment 9, we have also a gap. So you could instantly change them here. If you want to do roundness, cylindricity, it's easy to do some of the presets here. So let's go into, let's see, so program 9, you probably want at segment 3.
All right.
So go ahead and click that at the bottom middle there.
All right.
Right?
There we go.
And then if you click on detail setup here you can see what your averaging is. So if you wanted to change how many pieces of data are being sent across per second, or if you wanted a different timing or maybe more measurements to give you average measurements, you can change that here. And then tab 2, you can enter in your tolerances here. So you can do it in the front of the laser, or you can do it here in this. And again, you can change the type of tolerance that you want in this screen as well.
All right, so let's go ahead and do a little nice gap measurement here on a little sheet metal part here that we got. We'll use that program 9 there. I'm gonna set here using our little optional extra blocks that's normally hold for the calibration set.
So this is the optional hardware that he's showing here on this zoom in. So we've got the optional workstage here. So we've got some centers here, we've got some V blocks. And what's nice about this is that it will automatically position itself at the kind of focal distance that the laser needs for the most accurate measurement, right? And you can also vertically adjust it up and down. So if you want to position it to the middle of the laser, you can do it with this. Okay. So this is nice because you can set it up easily. Again, a lot of fixtures that we have.
All right, so we're going to go to send a setup for, again, program 9.
Program 9,
gap
3. Yep. So now it's sending all these changes that we did, sending them across to the laser. Should just take a few seconds. So this is the basic data acquisition screen. So this is nice. At this point, if you didn't want to use the laser for anything else, you could close QuickTool, and all of those settings that you made to the laser will stay. They will remember it in the laser. Everything's saved in the laser. So at this point, what he's doing is he's going across this segment here, and you can see on the screen some of the different measurements that you're getting. So if you go ahead and stop now, at this point you can see that he went to the edge, click stat, it'll give you all the same statistics that we saw before at a glance here. So the number of measurements, 32, average, max, min, range, standard deviation, all at a glance. And at this point, if you wanted to save this data to open it up into Excel later on, you could save it here, it'll save it as a CSV file, and you can open up in Excel. Or you can have an SPC software access that CSV file as well.
So we go ahead and save that. Now, we have this Cal P set here.
Exactly. So what this does is, say you wanted to preset it, maybe you have a master, you want to preset off the master, instead of getting a direct measurement, you just want a comparison measurement. So what you can do here is you put in your master, you can zero it out on the master, hit set, and then if we take a look at the laser again, at the close-up, you can see that once that's sent across, the display automatically zeroes, right? So now we're zeroed off on this part, whether it was a master or whatever, maybe it was a pin that you wanted to compare it to, you could do it here. So now you see the variation. Now you've got a comparison measurement instead.
And then just go ahead and get out of that. We just hit cancel.
Yep, cancel on the software, and then you'll see on the display again that it went right back to the previous measurement, the direct measurement. So again, the software is really handy for that. It's great for basic data acquisition, set up the lasers, really easy, easy to see, and it's not necessary to use long term. As soon as you've made your corrections or changes to the parameters, you can just close this and all of them will be saved in the laser.
All right, so I'm gonna go ahead and move some of these parts here. We're just gonna show how you set upper and lower limits. All right.
Okay.
Do
So
a
yeah,
go,
in
no
tolerances. So if we put the part back in, so this dovetails really nice. These V-blocks just slide right in and out. So let's go back to program 0.
go. Okay.
Program 0, if you hit the foot switch, we'll take a quick measurement, and see on the display here, see how it says go? So we know that this is in spec according to the previous tolerances that we've put in there. So you can just easily at a glance see if it's in.
And if it's out.
Now if it's out of spec,
whoa.
you can see on the LED, plus we have a buzzer set up so you can see that it's out of spec. So this buzzer is built into the laser also. So now you can see visually and then you can hear that it's out of spec. So if it's you or your operator, it's easy to tell if it's out of spec.
And to set those limits, you can set those limits exactly right in the keypad or also the Quick Tool software.
Yep.
So if I go ahead and press my limit button here,
Yep.
you can kind of see.
You can see here, so you can see in program 0. So in this laser, we've got 10 programs, but you can go up to 100 different programs. So in this one here, we've got the lower limit.
Mm-hmm.
So this is your limit low, and this is your limit high. So this is your upper tolerance, right?
Mm-hmm.
And there's different ways of setting it up as well. So if you wanted a plus or minus tolerance from a part, you could set that up in the laser as well.
Good stuff. Good
So-
stuff. So now with everything we went over through and all this good stuff, I mean, I'm sure there's questions that's out there that needs to be answered and Q&As. So we want to go ahead and see how many comments we got so far. We'll try to answer them out. Don't forget to leave all your extra comments down there in the comment section. Again, don't forget to hit your like button, your post notifications on, and you always receive any other future seminars, demos moving forward. So questions? Donna?
Yes, we have a question
Okay.
from Robert, and it sounds like this can be placed in line. Would a wide range of temperatures or dusty environment affect the accuracy of the results?
Okay.
Great question, Mike.
So yeah, good question. We have these in line. So if there's a variation in temperature, we're still guaranteeing the accuracy. It's 20 degrees C plus or minus 1, which is about 66 to 70 degrees. We do have these in other applications where it is a wider variation. So there's going to be a little bit more error involved in that, obviously. But let us know what kind of temperature variation you have. We also have some air purge covers. So if it's a dusty environment, these air purge covers are great because they'll mount right to the, not necessarily this all-in-one unit, but maybe something like this here, right, where you have separate units. So you can put these air purge covers on them, and it'll constantly be blowing away to keep the lenses clean. And that could be for some minor spray and things like that too. So a lot of times you're in a manufacturing environment and there's a lot of cutting fluid, oil in the air, right?
Exactly.
So this will help those keep clean. Plus it also helps the lasers keep a more consistent temperature too. So yeah, it's definitely something we can do with this, but let us know what your conditions are and then we'll recommend what we can use.
And you know what, Mike, just to add to that question, great job, Robert, we also have those closed-in housings too, right? Through the Custom Solutions Group, if need be, we can build a custom housing around that laser and or the display too, depending on the environment, right?
Sure, yeah, in some cases we've actually, whether it was us or the customer, one time a customer built an entire plexiglass enclosure around the laser. So they didn't have to have specific air purge covers. They had a positive pressure on this entire plexiglass cover over the entire laser with these slots through so that the laser would shoot through, and that served the same purpose.
Yep.
But yeah, our solutions group can also make, if you needed a turnkey system made up, then we can do that as well, whether it's here or our American solutions group or overseas groups.
Most definitely. Wow, we got a lot of questions here. What else we got, it looks like there?
Okay, we have another question. Can we measure straightness and form error with the laser scan micrometer?
Okay, so straightness or form error. So you can measure segment 1 or 3. So let's go back to the software actually. Let's go back to the setup here and I'll show you that.
Get out of here.
So setup. Nope.
There
go to
we go.
setup.
Yep.
And then go next.
Yep.
So if you're seeing the software right now, let's go back to a close-up on the software.
Yep. It's fine. Sorry,
Can you
great
see that there?
questions. I like it.
So anyway, so what we've got here, I don't know if you can see the software yet. We'll zoom in on 4. So there's a roundness and a cylindricity measurement here. So at a glance, we can click on cylindricity, and that'll give you the difference in segment 2, but we could use the same thing for segment 1, where you just slide it across, and if there's an angle to it or some taper, you could measure that, either with measuring the segment 2 or segment 1 or 3.
Great question. I like it. Keep them coming.
And we can do a max minus min with that as well. And in some cases we've got, if you wanted to measure the part, again, just like an indicator, we've put a linear encoder on the stage too. So if you wanted to track the linear encoder position to the height of the part, or the height of the part from the bottom, we can track those two axes together as well in software.
So you're just not limited. Great
Right.
question.
Absolutely, yeah.
Wow.
And it could be a linear encoder, it could be like a Digimax scale unit or a mic head, depending on which one you need.
We have a flood of questions here. Let's see. You got a good one here, Donna?
Yes, I have a question here. How often do I calibrate the unit?
Okay, so calibration, that's there's a lot of different things that you can do with this, but calibration is usually something that's selected in-house. I mean, we would recommend at least once a year is normal, but we don't have, it's really up to your internal requirements as far as how it needs to be used, how much you're using it. But what you should do once in a while is put multiple diameters in there and make sure that it's measuring all of them correctly. So if you have some high accuracy gauge pins or the calibration set, which we have here, you can calibrate it with those. If you need it traceable, you can send in the specimens to our cal lab here to have the specimens calibrated and A2LA traceable, for example, or you can do the laser, or you can do both. Or if you have your own pins though, pin gauges, you can get those certified as well. But what's nice about the calibration gauge set is that if you do need to recalibrate it, especially if you're at a different temperature like he was mentioning earlier on, if you know you're going to be at a slightly higher temperature, we recommend that you use a calibration gauge set that's been certified. So here's the one specifically for this laser. So you can see that the sizes here, there's one for the largest diameter, and then there's in the range. So for this one, it's 60 millimeters. And then there's going to be another pin which is just above the smallest end of the range, so I think it's about 1 millimeter. So depending on the range of laser that you have, there's a calibration set that you can just put in, and you can see this is set up for these specifically. So it's, again, set up at the correct focal distance, and then you can adjust it, so as soon as one's in the middle of the laser, the other will be 2 automatically. So we've got this here, and we can measure either one here and calibrate it with those. So hopefully that answers your question.
And
if
again,
not, give us a call and we'll let you know.
Most definitely. I know we have a lot to get to and probably get everybody's time, but please feel free to make sure to go ahead and leave all your comments there. We'll have a representative get back to you. Like our subscribe channel. Put all the post notifications on so you're instantly getting everything, okay? We do appreciate it.
Okay, we have a good question from Tony. Can I measure something like small wire diameter at high speeds?
Ooh, great question.
Absolutely.
Mike?
So the scan rate for these is already very high. It's 3200, so it depends on the application, but we can typically measure it in line at a relatively high speed. What we'd recommend though, in order to keep some of the bounce down, we do have some roller attachments, an optional accessory roller attachment that the wire can roll across so that you're presenting it to the laser very consistently. So we'd recommend something like that, whether it's ours or your own, something to present it to the laser. But yeah, we can measure these in line. In some cases, if there's certain vibration, we need to compensate for that, depending on the fixturing. But yeah, that's something we can do too. And the averaging that we have built into the laser, we have standard averaging where it's doing groups, or we have a moving average. So normally if something's going to be in line, we have this moving average that you can set up the laser to do instead. So sometimes that gives better performance for measuring inline high speed.
Great question, great question. We got some more here? All
Yes,
right.
we have another question from Glenn. How do I set up the foot switch?
Oh, easily. I mean, we got here just my little cable. We can come back here to the display. You probably see this little cord, but actually on the back of either your external display type or the built-in type, there's a foot switch jack that you can actually just plug it right in there. Most common commercial foot switch. So I'll go ahead and pull this out. Here it is right here. If you can kind of see my hands here. If not, same thing. It just goes right inside the back and plug in there.
So this is a mono plug too, so it's a standard stereo type plug, but it really is just a momentary contact for this. So we've also had customers make up their own. In some cases we've had it for these or other devices where this mono plug they've hooked up to a relay switch, and say they have, it's moving into position and they want to trigger the measurement. So as soon as it hits like a proc switch, it'll trigger that measurement with the foot switch. So you can have it almost like an automated system as well.
Oh yes, most definitely.
Okay, we have time for one more question,
Okay.
and that is about how many programs can the laser scan micrometer hold?
So for this laser here, which is the all-in-one, we've got 10 programs for
9506.
this, 0 through 9. For everything else, it's going to be 100 programs. So we have 0 through 99. And also with the foot switch, to get back to that, we have some new types as well. So if you wanted just a hand switch, we've got a little hand switch, button switch that's pretty nice. We also have an industrial or heavy-duty foot switch. So if you think there's going to be a lot of oils or if you're really going to be slamming this thing down, we have a higher end, standard foot switch too, which is a beefier foot switch. So
Good.
I think that's it for now. So again, thanks for your time. Now we're going to
Yes.
finish it off with Donna here.
Thank you, Mike, and thank you, Curtis, and thank you for joining us for this event. If you would like additional information or a demonstration, please feel free to contact Mid-Toyo America Corporation at 888-MIDITOYO. That's 888-648-8869. And ask for me, Donna Booth, at extension 3629. Or email me at donna.booth@miditoyo.com or use the link in the chat. We will be happy to set up an appointment. If you enjoyed this event and would like to see more, please like and subscribe to our channel. And once again, thank you and have a great day.